Hello again. Today we're looking at the Putnam 1986 problem A2 from this exam. The problem is this. Let's say that you have this expression, 10 to the power of 20,000 divided by 10 to the 100th power plus 3, and then rounded down, or greatest integer not exceeding function. The question is, this is going to be an integer. What is the units digit of this integer? So that's what we're trying to solve for, is the units digit of this integer. So first thing I'm going to do is, and of course, stop the video if you feel like you want to try to solve the problem yourself. See if you can figure it out on your own, and then we can compare and see if we solved it the same way. I'm sure that there's multiple different ways to solve it, but here's the way I'm going to solve it. So I'm going to let x be 10 to the 100, so that I can think about this expression as a little bit of a simpler expression, x to the 200 over x plus 3, rounded down. Okay. Next, I guess you could do maybe some sort of long division of polynomials, but I'm going to do a little trick here. Now, I want to change the top so that it's going to be divisible by x plus 3, or in other words, so that the top is equal to 0 and x equals minus 3. So what I'm going to do is I'm going to introduce another term on top, minus 3 to the 200th power, so that when you plug in minus 3 into the top, that obviously makes it 0, therefore x plus 3 must be a factor. And we'll factor this a little bit later. But for now, since I changed the problem by subtracting 3 to the 200th, I've also got to balance this by adding 3 to the 200. Okay. Now what we can do is we can look at this part right here. Because x is really 10 to the 100th, and 3 to the 200, you can simplify into 9 to the 100. So this part of the problem becomes 9 to the 100th over 10 to the 100th plus 3, which is obviously bigger. So this is a fraction between 0 and 1. And, well, this part, because that's an integer and that's an integer, and this divides into it, it's all going to be an integer. And your greatest integer not exceeding function is just going to throw away the, the part left over between 0 and 1, which is exactly this part of the problem. So this is just going to go away, and we're just going to be left with this expression. And because that's an integer, there's no need to do the greatest integer not exceeding function around it. There. So now that's a lot cleaner of a problem, and we're still trying to solve for the units digit. So let's continue. Okay. Now I'm going to factor the top using some factoring rules, or you could do long division of polynomials and eventually, figure out the pattern. But it's going to be x plus 3 times x to the 199 minus 3 times x to the 198 plus 3 squared x to the 197, and then that's going to keep alternating, eventually ending in minus 3 to the 199. Okay, great. And then, of course, the x plus 3's cancel. And so you're left with x to the 199 minus 3x to the 198 plus 3 squared x to the 197 minus ... Let me put the next to last expression. So plus 3 to the 198x, and then minus 3 to the 199. Okay. Next thing we can observe is that since x is a power of 10, well, when you add up powers of 10, that's going to give you a number that ends in 0. Okay? So all of this adds up to be a number that ends in 0. And when you add that to another number, whatever or subtract. Basically, this part won't affect like the last integer. And we really only need to worry about this part right here. Or another way of stating it is, if we can figure out what this is congruent to mod 10 as a number between 0 and 9, then that's going to be our units digit for the entire thing. Okay, so we've reduced the problem down into figuring out what is -3 to the 199 congruent to mod 10. Okay, let me clean up the chalkboard and we'll continue in a second. Okay, so here we have what we're trying to solve, -3 to the 199. What is it congruent to mod 10? Okay, so first of all, we can break that up into 3 to the 198 times 1 extra 3. And 3 squared is 9, so we can rewrite this as 9 to the 98th. But 9, and this is all mod 10, 9 is congruent to -1 mod 10. Oh, not 98th power, it's the 99th power. Much better. Okay. Then finally, -1 to an odd power is -1 times another -1 turns into +1. So this simplifies to be 3. And so since that's what this is congruent to mod 10, that is also going to be the units digit of the original expression. So final answer is 3. All right, so hope you like this video. Hope to see you in the next one. Have a good day.